Welcome back. So we'll continue the discussion on internal combustion engine. The topic valve timing diagram. So what is a valve timing diagram? You know what valves are. So they are used to allow the entry and exit of the fresh charge and the combustion products respectively to and from a cylinder combustion chamber in a 4-stroke engine. Valves are exclusively included in a 4-stroke engine only. In a 2-stroke engine, as we have seen in the last session, only ports are there instead of valves. So there we use port timing diagram. There is no valve timing diagram. Instead of that, port timing diagram can be drawn for the 2-stroke engines. So valves in a 4-stroke engine do not open or close at dead centers in practical. So theoretically saying, we say that the intake valve will open when the piston reaches the top dead center, right? Theoretically, but actually that's not the case. Just before the piston reaches the top dead center, the valve will open. Similarly, the exhaust valve. So, but they operate before or after the dead centers. The same is the case with the ignition also. So, we say theoretically that the ignition, the spark plug in the case of a petrol engine, will initiate the combustion when the piston reaches the top dead center. But practically, actually, that is not the case. It can happen just before the TDC, when the piston, before the piston reaches the TDC. So the timings of these sequence of operations or events, that is when the exhaust valve is opened, when the intake valve is opened, when the ignition starts, all this could be shown graphically in terms of crank angles. You know what is a crank, right? Crank angle means the revolution of the crankshaft. For a 4-stroke engine, in order to complete all the 4 strokes, the crank should make 720 degrees of rotation. So we can use that crank angles to pictorially represent or graphically represents the opening and closing of the 2 valves as well as the start and end of ignition from the respective dead centers. So this diagram, such pictorial representation of the sequence of events in terms of crank angle is termed as valve timing diagram. So please note, please understand what a valve timing diagram is. So this is a graphical representation of timings of the sequence of events such as the opening, closing of valves as well as the ignition in terms of crank angles from the dead centers. With respect to the dead centers, we will represent this opening and closing as well as ignition timing. Clear? Okay. So let us see. This is a practical case. Theoretically, so this is a top dead center and this is a bottom dead center. Okay, this point. Fine. Theoretically, the intake valve should open when the piston reaches top dead center here. But actually, you see, actually the intake valve opens before the TDC, before the piston reaches TDC. Similarly, the exhaust valve should open when the piston reaches bottom dead center theoretically, but actually it opens before the piston reaches bottom dead center. Fine. Similarly, the closing. IC means inlet valve closing, EC means exhaust valve closing. So closing as well as opening, both are not happening at the dead centers but before or after the dead centers practically. So let us see how to draw this valve timing diagram. So first of all, you have to draw a vertical line, this green vertical line, which represents the top and bottom of those lines represent top dead center and bottom dead center. Okay, this is a valve timing diagram. So first we are going to draw the valve timing diagram for a 4-stroke petrol engine. Fine. This is the top dead center and this is the bottom dead center. So this can be drawn by properly measuring the actual opening and closing of the valves from a cut sectional view of the cut section of a 4-stroke petrol engine or 4-stroke diesel engine. So you can plot this by conducting an experiment on an actual engine. From the cut section of an engine, you can measure these crank angles and plot it on a paper, and you can get this actual valve timing diagram. Theoretical valve timing diagram, it is very simple. The closing as well as opening of the valves will be at the dead centers. So here what I am going to explain is how to plot the actual valve timing diagram. So for that you need to draw first a vertical line which represents the top of the vertical line is the top dead center and the bottom of the vertical line is bottom dead center. So inlet valve opening is the first one what we are going to plot. This red arc semicircle represents the intake stroke. Okay, so intake valve opens, for example, 10 degree before TDC. Inlet valve starts to open typically 10 degrees, 10 to 14 degrees before top dead center. So this is the first point. Now draw an arc using compass with appropriate center till here, and you can see that the inlet valve will be closing after bottom dead center. Not exactly when the piston reaches bottom dead center, but still when the piston starts the reverse motion from bottom dead center, only the inlet valve will be closing. Okay, so 180 degree plus 10 degrees plus further some degrees after BDC. So more than 180 degrees the inlet valve will be opened. So this red arc represents the inlet valve opened condition. Then after that compression will be taking place. Then at the end of the compression the spark plug will ignite. That also will occur before TDC. Before the piston reaches the top dead center, when the pressure and temperature rises, the ignition will begin. Typically 12 degrees before TDC. So you have marked that point also, ignition point. Then the expansion stroke. You are marking the expansion stroke further by an arc. Now, before the expansion stroke completes, theoretically, it should be completed at the bottom dead center. Before that, the exhaust valve will open. Exhaust valve will open before the piston reaches the bottom dead center. This is the exhaust stroke, and the exhaust valve will be closing after top dead center. Not exactly at top dead center, but after top dead center. Now you can see that there will be a condition where both the valves will be opened simultaneously. So this here 10 degrees and here some say 4 or 5 degrees after TDC. So during this period of time, both the valves, intake as well as exhaust valves, will be opened. Then you consider a continuous cycle. So immediately after the exhaust valve is fully closed, next cycle starts. Next stroke, intake stroke will begin, right? But the intake valve will open before the exhaust valve is closed at this point, isn't it? So both the valves will be opened for a period of time. That is called valve overlap. That is called valve overlap. So this is the way of plotting the valve timing diagram for a petrol engine. The similar procedure would be adopted for the plotting of valve timing diagram for diesel engine. I will show you the valve timing diagram for diesel engine. So there will be slight difference for the angles, that's all. The procedure remains the same. So here another method is employed. We have started from the center with a shorter radius arc is used to plot the intake valve opening condition, intake stroke, then the compression stroke, expansion stroke, and just by a spiral curve it is used to represent. Previously we have started from the outer, I mean larger radius is used to represent the intake stroke. So both the ways you can plot. Either you can start from the larger radius or shorter radius for the intake stroke. Both are correct. Anyway, you have to use different colors to plot the different strokes. That will make the diagram clearly distinguished. The different processes could be distinguished properly and understandable. Okay, this is for the 4-stroke diesel engine. So there will be a condition where where both the valves are opened. That is called valve overlap period. So the angle between the inlet valve opening and exhaust valve closing is known as the angle of valve overlap. So this is how the valve timing diagrams are plotted. I hope it is clear. It is very simple, but it is very important. Now coming to the port timing diagrams for 2-stroke engines, this is a typical port timing diagram. So you can see the inlet port open here during the compression when the piston is moving from bottom dead center to top dead center. The inlet port will open, the inlet port will close practically during the expansion stroke only, when the piston is coming downwards, but the transfer port will be opening here before the piston reaches the bottom dead center. You can recollect the diagram which I have shown in the previous session, and the transfer port closes before the piston reaches the top dead center further. Then the exhaust port will be opening in between the top and bottom dead centers, and the exhaust port will be closing between the BDC and TDC. So this is how a port timing diagram is plotted. Now between this port timing and valve timing diagrams, the valve timing diagram is very important, because usually we plot valve timing diagram, and that is very important to understand the operation of valves and how much charge may escape out during the valve overlap period. So our aim will be to minimize the valve overlap period and to understand at what angle of crank the valve is opened and closed, and what position the ignition is started. Actually the ignition starts before the piston reaches TDC in order to ensure that there is sufficient time for the charge to burn completely. So that is the reason behind the ignition to start before the piston reaches TDC. So that's all about the valve timing diagram. So please keep watching. So more videos will be coming soon in different aspects and thermal engineering subjects. So if you are not subscribed, please do it by clicking the icon here, and please share with your friends, those who are interested to learn this, especially in mechanical engineering field in different institutes. So thank you for watching, thank you for listening, keep watching, have a good day.